I suck. Okay, so that problem probably looks familiar. I think. Hopefully. Maybe. Yeah, same one we did last section. But we're now doing things in terms of y. So I should actually try to give you a second. These are kind of the two. We did this one on what day is what? Thursday. This is like time change thing. Like I lose like 100 IQ points if I even have that to start with. For the next week, like it kills me. Is everybody else like that? Like I'm dying.
I was dying.
I was like okay this morning, and now I'm just getting like slowly just fading. Anyway, this is what we did on Thursday, and some of the things I wrote up here might not make a ton of sense because you had nothing to compare it to then. And this is what we're doing today. And they're both finding area. It just depends which way you look at it. So is there a spot in your book that you could like write down? You have to get some other paper there. No, I mean there might not be, but that is information that you would want. There's what?
0.5 and 6 between
8.5, 8.6. Between 8.5 and 8.6, there's a blank page. There's going to be 2 more. So leave space. There's going to be 4. Yeah.
Wait, Mr. Davis.
Yeah.
This is what the page is for. I don't know. And I'll be good. Or should I leave?
Yeah, 4 is good. Actually, I lied. There's 6. There's 6. So go like just do like across. I wouldn't split it up. There could be 6. I'm sorry. I lied a second ago. There was 4. I said there was 4. There's 6. I don't know. I totally know that.
The guy
Mr. Rust. So, if you're wondering what, especially that's like hard to see. So when we're doing things in terms of x, it's top minus bottom, and this is like, it's called a representative strip. So it pokes through the 2 equations. The first one it comes to is the top, the second one comes to the bottom. And this is the same idea but right minus left. So it's called a representative strip. You draw it horizontally in this case. The first equation that you hit is the right, and the second one's the left. So that's an R and an L on the bottom one. Seems unsafe.
Wait, Mr. Davis. You never told us how our next test is. Oh, yeah. What did you even say?
We just started with you with this head, no? I don't know. What?
You take home?
No. We talked about it a little. I said your test left. Next test.
You can just take it down.
Your next test, like half of it will be just set it up. Yeah, I rambled for so long, Antonio. Like,
No, I'm listening. I'm writing down stuff.
please hold so you can finish your story?
I'm not telling a story. We're trying to get. We're interrogating. She started a story and then reviewed the story.
That's alright. You said you do that like every day. I mean, just like really happy if you like started. What? What? I see whiteboard reads.
Influencers. They'll make videos and they just like write, go write like, they'll do that.
And people watch this.
Yeah. Millions of views. They get hundreds of thousands of dollars.
Alright, screw it up. We're focused on that.
Like, we make so much money.
Okay. Whiteboard. So on 5, please. You're still not done writing? Very good. On Thursday, we did this problem in terms of x. So in terms of x, is equal to solved for y. In terms of is like the variable that's on the other side. And when we did the stuff on Thursday, the whole thing is in terms of x. All the equations were like y equals blah 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 x, y equals blah 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 x. These are two x values, the left hand x value and the right hand x value, and then dx. So when we did this on Thursday, we had from 0 to 6, because this is like a split point where the bottom equation changes. So from 0 to 6, your top equation is square root of x, your bottom equation is 0. Plus from 6 to 9, your top equation is still the square root of x, but now your bottom equation is that x minus 6. So hopefully that's familiar. It's up to you. I'm going to show you like today's way we do it in a second. So that's like the way we did it Thursday. There's 2 ways to do it. I'm using this problem to show you how to do today's assignment. So I don't know if you want to write it down. It's in your notes because you did it. You did that same problem on Thursday. All right. So today I want to look at what if we do it in terms of y. So in terms of y is the opposite of this. So we have to solve for x. So we're going to look at everything sideways. Instead of like top minus bottom, we're going to go right minus left. When you're looking sideways, things are in terms of y. So this is going to be x equals y squared. So this is x equals y squared. It's just a sideways parabola. It's not a regular parabola. And then this is x equals y plus 6. So this is x equals y squared. And this is x equals y plus 6. So we are going to do this in terms of y, which means every single thing we put in the integral has to be a y value. So we want the lower bound. This is lower and upper because it's y value. So what's the lowest y value of our shape? It's 0 because we're right here. What's the highest y value we go to? Is 3. Can you see that? Because it's up here at 3. And then the really nice thing about this one, A, it's like the lesson. So we're trying to teach that. But B, I don't have to do 2 separate integrals. So when I went vertical, think about if I drew a line there and I drew a line there. First one it hits the top, second one's the bottom. First one hits the top, second one's the bottom. So you can see how the bottom's different. If we go sideways, which equation's on the right the entire time? So you got an intersection there and an intersection there. That's the right-hand equation the whole time. and that's the left-hand equation the whole time. So we're only going to need one integral. So that's the nice thing. So I'm going to do right minus left. This is probably just a giant mess of confusion. So the right-hand equation is x equals y plus 6. The left-hand equation is x equals y squared. If you're not sure, you have a graph here, but if you're not, what can we do? Like say we don't have a graph. I'm going to plug it in. So pick a y value between 0 and 3. Let's say 1. So plug it in. What's 1 squared? 1. What's 1 plus 6? 7. So that one is further, has a bigger x value, so it's further to the right. So y plus 6 minus y squared. That first y plus 6 does not need to be in parentheses, but that's okay. Times cy. So everything in there is a y value. So the benefit is it's only one, remember it's just set up. It's only one integral. Downside is it's harder for most people to think like right minus left. Sometimes literally, like if you just take your book and like turn it sideways, then you can see like up minus down. It kind of helps you a little bit. Questions on one at all? Just 8.4 is this. This 8.4.
It's like it's the sideways version.
Yes. So number 2, we don't have a graph. No, we do have a graph. See this? Yeah, I was like, there's no graph here. We do have intersection points too. Let's pretend we don't have a graph. How about that? This doesn't exist. How do I find the intersection points? Set them equal. 3 minus y squared equals y plus 1. I gotta solve that. So that's a quadratic, so I want it equal to 0. So on that side, the y squared would be positive. The y stays there. The 3 would be subtracted, so 1 minus 3 is -2. So then I have y plus 2, and y minus 1. So y equals -2 and 1. And so if we looked at this graph that we can't see, there's your -2, there's your 1. So it's just the lowest point and the highest point in the function. And then again, I can't see the graph, so I don't know what's on the right and left. So I'm going to have to figure that out. So right now I know -2 and 1. These are y values. Yes, I'm going to pick a point in between -2 and 1. I'm going to use 0. So if I plug 0 in there, what do I get? 3. If I plug 0 in there, I get 1. 3 is bigger, so it's more to the right. It's got a larger x value, so that's your right-hand equation. And then the y plus 1 is your left-hand equation. What's up? Say let's go. Oh, I thought you said that's right. Questions on it? Does that make sense? Okay. Number 3 is a beast. I would say this is harder than one that you would ever see, but it's a good practice problem, so we're going to do it. We're going to do it both ways. Okay, we need all of these intersection points. So that's your first job, is to find those intersection points. Go. Like infinite. You can use calculator. You can graph them, you can use solver, you can use algebra. The bottom right point is not like, it's very calculator necessary. Not afraid. X and Y value.